This is problem 32.39, and we are given two functions, y1 and y2. We are asked to find the resulting phase and amplitude of y1 plus y2 using A, only trigonometry, and B, adding them up like phasors. So in A, when we're using trig, we need to use this expression here. And then y1 plus y2 is just going to be equal to 24 sine. This is A, the 4.5t, and then this is B, the 4.5t plus 70. So it's going to be 4.5t divided by 2 plus 4.5t plus 70 degrees divided by 2 cosine of 4.5t divided by 2 minus 4.5t plus 70 degrees divided by 2. What we get here is cancellation on this side and then an addition of the 4.5t over 2 on this side. So it's going to be 24 sine of 4.5t plus 70 divided by 2, so 35 degrees, times cosine of negative 35 degrees. We're going to take the cosine of negative 35 degrees, multiply it by 24, and what we get is 19.7 sine of 4.5t plus 35 degrees. So what we see is that the amplitude is 19.7, and then the phase is 35 degrees. We're now going to use the second method using our phasors. So remember what a phasor is, right? It's going to be just a vector where its magnitude is equal to its maximum amplitude. So here it's going to be 12 for both of them. And it's going to make an angle with respect to the horizon. So here, this one, there is no phase, right? It's just sine of 4.5t. So it's not going to make an angle at all. It's just going to lie flat along the horizon. And then y2 is going to make an angle of 70 degrees. So if I draw them out, this is y1. So I'm going to put that in pink again. And then y2, because we want to add them up, we're going to go from its tip like this. This is y2, and it is making an angle of 70 degrees. So we want to figure out what this resulting vector is, y1 plus y2. To do so, we need to figure out how long is it in this direction, so like the I hat direction, and then what about this direction, the j hat. So to do that, we need to first figure out what this height is here. And that's just going to be equal to 12 sine of 70 degrees. And this is going to be equal to 12 cosine of 70 degrees. So let's go ahead and add everything up. We get y1 plus y2 is going to be equal to 12. So this is 12. 12 in the I hat, that's for the pink. Plus, and then for the green, we're going to have 12 cosine of 70 degrees, that's also in the I hat, right? Plus 12 sine of 70 degrees in the j hat. So that's what we see there. If we add all the I hats and the j hats up together, we're going to get y1 plus y2 is equal to 16.1 in the I hat plus 11.3 in the j hat. The magnitude, we're going to call this yr, instead of saying like y1 plus y2 all the time. It's going to be equal to the square root of 16.1 squared plus 11.3 squared. And that's going to give us 19.7. And then the phase, to figure out what this angle is here, we're just going to use the inverse tan of the j hat, so 11.3, divided by 16.1. Okay, and that is it, because that gives us 35 degrees, and we see that the answer we got in A is the same as we got in B because we're just using two methods to talk about the exact same thing. So now we're going to do a very similar thing, but instead of adding up two functions, we're going to add up three functions. I'm just going to take a second to write them out, but they're all very similar. So we have 12 sine 15x minus 4.5t plus 70 degrees. What we're going to see is that this part of the equation, or the function, really doesn't matter at all when it comes to figuring out what the amplitude and phase are. 15.5 sine, again 15x minus 4.5t minus 80 degrees, and then y3 is equal to 17 sine 15x minus 4.5t plus 160 degrees. So we're going to use the phasor method, which just means drawing them out, figuring out what are each of their y components and x components, and then adding up those respective components. So we're going to again color code this. Y1 is going to be in pink, and let's just go ahead and draw that out. So it's a vector with length 12, making an angle of 70 degrees with the horizon. Obviously these angles aren't real, or representative of reality, but doesn't matter. This is going to be 12 sine of 70, and this is going to be 12 cosine of 70. Right, so now we have our j hat and our I hat for y1. For y2, it's a negative 80 degree angle, so it's going to look like something like this. This is negative 80, and here we have 15.5 as our magnitude, and this is going to be 15.5 sine of negative 80, and this is 15.5 cosine of negative 80, and we're gonna code this green. So we found these, and now for y3, very similar thing. It's going to be 160, so maybe pointing somewhere like this, and we're going to have a length here of 17. This is 160, and then we're going to have 17 sine 160, 17 cos 160, and we're going to color this blue. So now all we have to do is add up all the y's and add up all the x's, and I'm going to write all of that out for you. So here we're going to call the resulting vector yr. It's going to be 12 cosine of 70 in the I hat, this is for pink, plus 12 sine of 70 in the j hat. Let's color that here. Plus 15.5 cos of negative 80 in the I hat, plus 15.5 sine of negative 80 in the j hat for the green, plus 17 times cos of 160 in the I hat, plus 17 sine of 160 in the j hat. If you were to plug in every single one of those numbers and add them up, you would get yr is equal to negative 9.18 in the I hat plus 183 in the j hat. You could then figure out its magnitude, right? So this is going to be equal to the square root of 9.18 squared plus 183 squared, which is going to give you something like, I think there should be a dot here, it's 1.83, sorry, 1.83. And that's going to give you something like 9.36. And then to find the angle, again, you're going to do the same thing, draw that out, and you get 169 degrees. Okay, so very similar. You can add up really anything using phasors like this.